to answer the questions that were raised both in the Google form that we shared earlier last week and during a workshop that we held in January. And then at the end, if we respect the timing we've planned, we should have 20 minutes of question and answer, which will be live. You can open up your mics, you can ask your questions in the chat. So maybe that's also a very kind reminder for our speakers to try to respect as much as possible their timing constraints for their presentation. Thank you. So a bit of context. We're meeting today because of a discussion that we've had in January. So every 2 years, the Veolia Foundation and the French Water Partnership organize the Humanitarian WASH Workshops. They're 2 days of discussions, sessions, and demonstrations of WASH techniques, WASH subjects, and we gather all in person during those 2 days and share basically maybe new technologies that we've been using, methodologies, integration of other sectors and stuff. This is a huge picture from our workshops in January that we wanted to share. And basically during these workshops, we had a discussion on waste, on energy, and on WASH, in which we raised very technical questions that we didn't have answers to. So what we decided to do 9 months later is to organize these technical discussions, which will happen once a trimester, in order to answer those questions with experts from the sector. So we've tried to gather all the questions that were raised, and I organized them by theme and topics, and this is where we're at. So today we're joining, we're getting on the theme on water and trying to tackle the topics of desalination, RO, especially with saltwater and brackish water. And for the next one to come, that will be in December, we'll talk about energy, and then, as you can see, other themes that were raised. And we're hoping to continue end of next year with new themes that will have emerged during those discussions. So if at any point you want to go a bit deeper into the subject, please feel free to say it in the chat or open it to Monday or write to us. That's totally fine. I'll just maybe close your mics as you can, because it's quite a big chat. Thank you so much. All right. Maybe to start off with, I'd like to introduce the speakers that are here with us today and that we really thank, especially those that were also here this morning for the fresh session. Thank you so much for being here twice today. So we have Maud Rivoal from Solidarity International. She's a WASH coordinator, and she will be sharing her experience in her intervention in Gaza, and especially the accessibility constraints and other very subtle elements of her experience in Palestine. We also have Stephen and Andrew, both from Katadin, and they'll be sharing the different kinds of products that Katadin offers for NGOs on the field, talk about a couple of collaborations they have also in Gaza with different NGOs, and maybe try to give the private sector view on how we can answer to very technical field constraints and limitations by making products that take that into consideration. And then James and Favor are both from Madeira, so James is a WASH advisor consultant, and Favor is a humanitarian aid worker, and they'll both be talking to us today about the situation in Yemen and the way they have led their desalination interventions in that setting. So each of them will share with us for 5-6 minutes their presentation and their lessons learned. And then, as I said, we'll get into a discussion and answer some of the technical questions that were raised in January. So Maud, if you're still with us and still okay, then you can proudly start. That's okay? Or actually, we changed a bit the we changed the order from today, and actually we'll start with James and Favor. That's okay. Yes, plug twist. Thanks. All right. I don't know who's taking the floor, James or Favor.
I think Favor is going to take the floor now. Thanks.
Okay. Yeah. Thank you very much, and Good afternoon, everyone. It's a pleasure to join the session and look forward to actually learning a lot from colleagues. So I wouldn't take a lot of time doing the introduction, but I would quickly jump into our project. So in Yemen, we actually did construct 2 desalination units. One, we did it in one governorate, which is close to Eden, which is Lahaj. That is an area called Kodbihan. And then another one, we did it in Aldale. And that's why you can see the 2 pictures. The first one on your left, that happens to be the one in Kodbihan, and the one on your right would be in Aldale. Next slide. Yeah, so among the technical things that probably, just to give us a little background, what made us to actually consider desalination was that actually we had a lot of high salts in the water that is available for the community to use, and considering the fact that we had lots of water sources, but however they were not potable. And then largely before the war, we used to have piped water which was connecting the community which are near the cities. But I think because of the destruction, so people resorted to actually just finding shallow wells where there would be water, and then they would be able to get access that water. So it was not very safe when it comes to humanitarian standards in terms of the total dissolved salt, and then the high water hardness, and then the presence of the coliform. So as a result, initially we would do simple treatment method where we would try to source for a well that actually would meet the standard, and then do a lot of construction and do a lot of networking in terms of piping and all that. But that was going to be costly also in terms of sustainability. Next slide. Yeah, so yeah, you can skip that. I think that one is just a simple design of actually what we looked at. So among the things that actually we were considering is that looking at the communities in Kodbihan, this happened to be an area where we had a blend of both internally displaced persons as well as the host community. But you come in Aldale, we actually had the host community, but they were living in the frontline areas. And as a result of that, there was always a lot of mobility. But then nevertheless, we still needed to actually make sure that they actually accessed water. So among the things we actually did was to get a local contractor who actually was able to actually design and assemble this unit so that we could be able to set it up. It was difficult at the beginning because there was a lot of back and forth in terms of whether the technology is available in the country, whether we can get the right personnel to be able to set it up, whether we can get even the community can be able to then know how to be able to sustain it. But the good thing is that we targeted available energy, which was simplified using solar, and then we were looking at the amount of the output that the plant and the unit would be able to produce, because then it actually was definitely going to serve the community. And at the same time, we're also looking at the way, the mode in which this system would operate. You can see, like, we actually considered the pre-treatment. The reason why we had to do pre-treatment is because later in the unit, we actually do remineralization, and it was easier after we have pre-treated the water. We can be able to use the same water that we've already treated just to remineralize the water before actually it is released. Those are just some of the key points that we were considering when we're actually setting it up, because then the community volunteers that we took to train, to induct, we had to take them through all those factors so that they can be able to understand how to measure. That's why we had a flow meter, flow, high pressure, low pressure gauges. We had to take them through and then lastly, the dissolved salt is turbidity. So now that one we had to consider maybe linking them up with the water unit, water ministries, because they have the laboratories that they can be able to come and do testing. Next slide. Yeah, so now, why did we consider, for example, solar as an alternative energy to support desalination? Because we are looking at an energy mechanism that is available and is also sustainable for the community. So solar actually came out to be the most probable successful one beyond the project, because alternatively, like all their water points, they were always running them on fuel, on diesel or petrol run generators or pumps, and those ones were not sustainable, because when then the community would not have the money to actually be able to pay for it, then that system would actually not function. And we were thinking, if we wanted to make the desalination unit something that is sustainable and beyond even our presence We are now, I think, I would say half, like 9 months out of the country, but at least the unit are still running. Like Code has been functioning for the past 2 years. So at least we can use that as a success, that it's actually a plan that we're able to set up. And among the things, maybe some of the differences that we're able to put between the one in Kodbihan, which is in Lahaj, and the one in Aldale, were the number of beginning, we provided a reasonable number. We did not put so many of the panels, but then we realized later, because Aldale is a place where half of the year it actually rains, and then the other half is actually sunshine. But you come to Lahaj, better part of the year is actually sunny. So they have more sun presence, which then actually supports for the solar energy. And it's very easy. A lot of the community members were former retired engineers. So it was very easy to actually just do a brief induction, and then they'll be able to support the plant. Next slide. Yeah, you can skip that one. It's just something for information about the output. Yeah, so I was just trying to think something that maybe might be very good for us to consider. Like, for example, the solution that actually we considered would actually be workable in a country like Yemen is actually the use of solar. So whether we are actually doing desalination, whether we are doing a water unit rehabilitation, we always considered the solar energy, and that actually has worked, because most of our rehabilitated water points, or either distribution of the water as well as the desalination, we worked with solar. And what are some of the advantages that we have when we are using solar? For example, we have the sustainability and availability. They actually have sunshine throughout the year, so that means they do not need to struggle to access the energy. And then at the same time, the maintenance, once the system is functioning, all they do is to have to clean the panels probably once in a week, and then in case and then monitoring of just the system that actually it is functioning. And maybe a disadvantage would just be that we realized not all of them. Sorry. We realized that not many of their engineers would, for example, troubleshoot if there is a fault, a technical fault on the wiring. But how did we mitigate that? We had to pair the contractor who actually did the designing of these units together with the volunteers during the construction phase. Then they are taken through a refresher and orientation, and that supported us greatly. Next slide. Yeah, so I've mentioned about use of the local expertise. I mentioned that I think one advantage we saw in Yemen is that in every family there was either a doctor or an engineer. So it was very good that you'd always find in a village there's this one retired engineer who used to work in one factory or one plant. So these volunteers would actually offer themselves up to support. So we took them through training on how actually to operate the desalination unit in terms of changing the membranes, monitoring actually the gauges, and as well as also servicing in case there is maybe a fault on the electricals. At the same time, we also connected them with actually contractors that actually had expertise in this. Like the two plants were designed by engineers that were in Yemen, and these engineers assembled everything from the beginning to the end. So we actually connected the local volunteers together with the contractors to make it easy that at the point of where there is maintenance, because there was a guarantee that we signed with them for 1 year beyond the project. And so they would always come to do regular checks, maybe every 3 months. And during that time, they're doing it together with the community. And among the best practices that probably we saw was that actually working with the retired engineers in the community provided a very good pool of actually personnel that actually could manage the unit, because the biggest challenge with desalination plant is if you only export the engineer who comes from, let's say we were working in the south of Yemen, you bring an engineer from Sana'a. Once he has constructed and he goes back to Sana'a, then it means when there's a problem, that plant cannot be serviced. And then using locally available material, I realized our engineers were sourcing most of those materials in the country, in Yemen, like the carbon filters, the chlorine that they needed to use, and even all the equipment that they assembled, they were all available already in the country, and that provided and made it easy for them to work. Next slide. Yeah, I think we can skip that. It's a repeat of the other one. Good. And challenges as I round up is just technical complexity. Yeah, it required actually skilled personnel. So we struggled to get the right contractor to get, I wouldn't say it was a walk in the park. It was difficult to get a contractor who could assemble the whole unit. Most would work on different bits and pieces. And for a project, you don't want to get one person to do the beginning and another person to do another end. You'd like somebody that can run the whole of it. Then cost of setting it up. At the beginning, many contractors we could not estimate how much it was going to cost because like it was seen like a new technology. But for the second one, it was very easy because we already knew the bits and pieces we needed to do. When it comes to environmental impact, yes, the brine management was also a concern, but at least for us, what we did was to try and make sure that for every of the brine water, we actually had soakaway pits that actually were constructed away from the plant and as well as away from where the population was living. And then lastly, connecting them to the water department because regular testing of the water. Thank you.
Thank you very much, Favor.
You're welcome.
James, do you have anything to add,
Yes.
or can we go ahead?
No, I don't have anything to add. Thanks, Favor.
Thank you. You're
Amazing.
welcome.
Thanks.
Thank you.
Favor. I remember back in January during the workshops, there was, really lots of questions around. The RO technique is necessary for it to function. It needs so much energy. And even though we won't be able to lower the amount of energy it needs, how can we diversify the sources of energy to make sure that we're not, in the end, not able to put in place that technology because of if the source is not available anymore. So hybridation was a big question around that in January on how we could use solar, but also not only solar, because in certain places it's not possible, or at certain times in the year we can't rely on it anymore. So definitely great to also understand the different limitations and specific constraints to Yemen that you experienced. And I think that's a great transition for Maud to take the floor, and she will share with us the specificalities in the Gaza context and how Solidarity could also adapt the way they would do desalination because of that context. Maud,
thank you.
up to you.
So good afternoon, everyone. I will discuss with you about the water production through the reverse osmosis in Gaza Strip, mainly in emergency context. Let's go. I will just start with a bit of context just for you to understand, but I guess most of you have already an idea. So most of the population has been multiple times displaced, and since March 18th, there is more or less 850,000 people who have been displaced again. There is also a 96% last July of the population who were evaluated by the WASH cluster, who were saying that they are facing moderate to high water insecurity, so they do not have access to water. Water in Gaza means drinking and domestic. So there is two kinds of water. It was already before the war, but it's drinking for mainly cooking and drinking, and more if possible, if available, and domestic for laundry and cleaning and showering and so on. Then also just for you to know, because there was a big thing about water quality and mainly chlorination in Gaza. So in last April, 85% of the households were not consuming water with sufficient chloride or FRC. So that's for you to have an idea. Also to consider that in Gaza, there is a lot of what we call evacuation orders. So you receive a message from the Israeli army saying that this area have to evacuate. Following this, there is a lot of infrastructure which are not reachable, let's say, or safely reachable. And it's a small table that you can see. I will not go through, but it just gives you like an impact on the WASH infrastructure in Gaza today. It's all from September. On the map, it's you can see it. So all the red are the areas which are under evacuation order or occupied, and only the white one is where people can be, what is more or less called humanitarian zone. And you can see all the dots are the water wash infrastructure. So really small number are still available. It means that the water production has been reduced, but also there is lack of energy. It's very complicated to find fuel, and there is no more power grids, and solar has been a lot destroyed, and it's quite impossible to make it coming in. So all this has a big impact on the water production and availability to the people. We can go next. Based on this, as I build a strategy by trying to produce more water, domestic and drinking. Domestic because by providing domestic water to people, it's releasing the pressure on the drinking one. At the same time, we did a partnership with a local NGO who was before producing drinking water, and we gave them the means to restart their station and to deliver water and safe water to the people. So I'll go on the next one. Very good, thank you. This is a small RO, which can produce 120 cubic meter per day due to fuel, difficulties to access, and so on. We are producing more or less 100 per day. We did a first check with the local partner to look at the rehabilitation to be done. So the main water tank was broken, there was electricity issue, membrane, and just for you to know, before it was solar and power grid energy used for the RO, but all the solar panel has been stolen and there is no more power grids. So we rent a generator and support them with the fuel organization also to run the best as we can with the fuel available at the station to produce as much water as possible. Technical support, more specifically on the water quality and also water quality material and how to perform analysis, what the regularity and all. We tried to use as much as possible local material, but also because it was so complicated to make anything under. And it's still, I think. So that's what we started. Here you can see what I called synopsis of the station. I'm very sorry about the picture, they are not good, but that's what I managed to have. So the first one is the borehole, then the rose water storage, the RO, the chemicals and all what you need to make it run, then the drinking water storage and the filling station for the water trucks. Can go next. As Favor, already explained, so we had some limitations, some challenges. The first challenge that we are facing is the loss of yield and performance of the RO because it's very complicated to make the normal and regular maintenance, to change the membrane and so on. We are mostly trying to keep it as much as possible and then to change when really it's necessary. We also have issue with the energy, as you understood, the quality of the consumables. For example, for a long time, the antiscalant was almost only water, so it was very complicated to also keep the membranes. There is also a problem with fluorinated water among the community, which is another part. Security, and there is also a lot of population movement. So each time you put the truck somewhere or you distribute water somewhere, you need to move your truck the day after. So that's the main challenges. And just on my side, I want to emphasize that we use this and we started this project in Gaza and in emergency because it was existing before, because the partner had all the competencies to do it and the experience, and we just reinforce and support them with material and what they cannot access easily or offer. So that's really for me big point because reverse osmosis is not a technology you can easily implement in an emergency or a new technology you can import. I think that's it on my side.
Yeah, thank you so much, Maud, for this dive into the situation in Gaza. It's very great to see how each organization is trying to adapt as it can and still trying to impact as much as it can despite the situation concerning access and materials and local expertise available as well. So thanks for this. Make sure if you have any question that you want to ask either to Meder that we've heard before or Maud from Solidarité and Stephen now, you can write them in the chat as the presentations go. And we have a dedicated question and answer phase at the end of the session. So we'll make sure to answer your questions, but you can already write them in the chat. Stephen, I know we can't see you, but if we can still hear you, you're up to tell us a bit more about how Katadin is trying to make equipment that is adapted to a context where the energy sources are maybe not limited.
Stephen, we cannot hear you well.
Yes, you're very far, but we can see him. Oh, great. Are you using headphones by any chance? Or yeah.
Yes, he's there, but he's talking. I cannot hear you, Stephen.
Can you try maybe choosing another source of audio in case you're using Bluetooth or headphones maybe? Or you can try to log out and log back in again. With such a beautiful landscape, we cannot afford not to have you to present your presentation. We want to know about these mountains.
Yeah, I saw that you are not mute. You don't have any headphones, but we cannot hear you.
Yeah, I see. Hear me now?
You sound from very far.
Yeah.
No, he's still.
Stephen, do you want to try to log out of the call and come back in? Maybe the audio will be better.
Okay, should we maybe in the meantime, while Stephen is trying to.
But yeah, maybe
I see that there have been 2 questions in the chat.
Amazing.
So there is one about Maud's presentation. So Marielle was asking if we could go back to slide 2 on the activities. And she was asking which has been the most challenging at this current period.
Can you hear me?
Maybe. Oh, yes.
Yes.
Okay, I fixed it. So.
Okay.
So maybe
Marielle
we
is
can
okay
go.
with waiting a couple of minutes more, then we'll go through Stephen's presentation and start with that question. Thanks, Marielle.
Okay, so let's go back to reverse osmosis and especially reverse osmosis with energy recovery. Next one, please. Yep. So reverse osmosis has been discussed previously in our other workshop and presented to have many advantages because it's pretty universal. You can use it on every kind of water, from fresh water to brackish and seawater. So it opens the supply even to seawater, which is pretty interesting. There is a lot. It's a big source. We can rely on local water, even though we don't know what the quality will be in emergency and disaster situations. So that's a pretty good point. But I've heard a lot, and this has been said previously today, again, that there are a lot of challenges. And those challenges are, first, a high energy consumption, especially in a context where the energy is not easily available. And second, pretty complicated and costly operation and maintenance. The third one is the environmental impact of the brine rejection. But as I mentioned, we are a manufacturer of equipment, so we are not really involved in this implementation of our equipment on the field, even if we are happy to support and provide solutions or path, but we focus more on the product itself and the technology. And today I want to talk about how we can solve these two main challenges, which are high energy consumption and difficult operation and maintenance. What is usually quite often used is kind of conventional reverse osmosis, which is available all over the world. There are a lot of systems like that, which is easy, simple, but a little bit basic. We are, but other manufacturers as well, we have developed a special kind of reverse osmosis, which use a proprietary pump. For us, we use a special one, which is the person pump. I will talk about it. You can see on the picture. We have another pump, which is the Clark pump for smaller systems, but that's the same principle. So this pump is a high pressure pump, which offer energy recovery, which means that the pressure, the ejection pressure of the brine is re-injected in the circuit automatically by the pump itself. Systems with this kind of pump are working with a fixed recovery rate, which means that whatever the features, the quality of the water at the input, we will have the same output of 50%. These pumps have been, and this system have been extensively tested and developed, and we have a lot of field, I mean, it's a field-proven technology since 15 years or more. Even though it's pretty new in the WASH environment, we have been using these systems in the marine business, where people need low energy and are not really available to operate this kind of system on a daily basis. So, and we have adapted it to the WASH environment. So what does it consist in? So I said we re-inject the pressure of the brine, and which allows us to need less power supply from the outside. Then, due to the design as well, the mechanical design of the pump, the system operates always at the lowest possible osmotic pressure. There is a self-adjustment to this lowest osmotic pressure according to the temperature, the salinity of the water, and so on. So as a result, as we are working with a pretty low pressure, we have pretty low energy consumption compared to conventional RO. The energy consumption is for such a system roughly 25% of what is used otherwise. That makes it pretty ideal for solar power supply and adapted to this kind of context, as Meder was explaining. And with that, we have a constant and reliable output, whatever the water source as well. So low energy and constant water output. The other consequences and good assets of this energy recovery and fixed recovery rate is the easy use and the simple maintenance. Why? Our systems are basically simple start and stop operation. So you just start, you just stop. We don't need any operators to fix the pressure of the system according to the different qualities of the water or the changing qualities. Nobody has to be here to analyze the water, to analyze or follow some abacus or some whatever calculation to see what pressure need to be used. The system itself will adjust mechanically. So, which means that nobody needs to be here, and the system adjusts to the lowest osmotic pressure. So, which means that it maintains a low pressure on the membrane, and there is no risk of excessive high pressure and damaged membrane due to this over-pressurized situation. So it's pretty easy to use, no need of expert operator, and no, limited risk of breaking the system by wrong operation. The system is operating alone. Low maintenance, why? As said, we are operating the membranes at the lowest pressure possible. That helps to have a longer life of the membrane, of course, because there is less risk of damage, and first, there is less pressure on the membrane. Another thing linked to this low pressure is what we call the cross flows. As we have a limited high pressure to have the water go through the membrane, there is less water going through the membrane than in a conventional system, but there will be more water circulating around the membrane, across. That's what we call the cross flows. And this circulation of water along the membrane will eliminate need of membrane cleaning. That will help to avoid any scaling, which is quite common in RO on the membrane, and which usually is one of the first source of damage. So as a consequence, the track records of this kind of equipment shows that a membrane can last up to 6 to 8 years or more without any complicated maintenance. So just to say that I wanted to present the technology that we are using that solve the two main challenges, at least the technical ones that are usually faced in RO use. I just have to illustrate that. Next slide will show one of the systems that we are deploying in WASH situation. So this one
maybe we can take just 1 minute, Steven, to go over this, just to be conscious of time.
Yeah, right? I will. Like this morning, I do it very quickly. Just want to show that this equipment is the more mobile and small. So just to say, we are doing 16 cubic meters per day with that at a TDS of 32,000, so which is really seawater. 50% fixed recovery rate, as we say. So 1 liter in, half a liter out. And if we look at energy efficiency, it works with a 2.6 kilowatt hour on seawater, so which means 3.9 kilowatt hour per cubic meter. And to do a small comparison, because it can be easily used with a small generator of 3.5 kilowatt, usually with 1 liter of gas oil, oh, I see it's in French, sorry. With 1 liter of fuel, of diesel fuel, we can produce 1 cubic meters of fresh water. And this is a basic equipment which can be fixed with, daily tools, nothing special. It's pretty easy to assemble and pretty easy to carry. We have systems going up to 75 cubic meters per day. These ones are more fixed in containers, for instance, but they work with the same technology. Here we are.
Perfect. Thank you very much, Steven, for telling us about the technology.
And if you have more technical question, I have Andrew with me, who is really the technical guy of Catalin Desalination. So, and he's here and available for if you have a more complicated question that I couldn't solve.
Okay, sounds great. Maybe as Marco said, we have some questions in the chat. Maybe we'll start with that. As you're there in the room, and we want to make sure that we answer your questions. And then if we have some time, we'll go back to the questions from the workshop from January. I'll stop sharing my screen so we can see each other's faces. Feel free to turn your cameras on. And as I promised, we'll go back to Maria's question to Maud. If I find it in the chat. Yes, on the activities that Maud presented, which has been the most challenging of the activities as at the current period? Maud, would you be able to answer that question? I can go back to this.
Yeah, if you could please. So just on my side, I left Gaza since 2 months, and I'm since on holidays, so I do not have like the last news or the last context and so on. But just like it's a bit complicated to answer because all over the time, all the changes are different. But the main one is fuel, but that in the meantime, it's really something that only the UN can like make advocacy, whatever, to get it. And then the second and the main one is really spare parts. For example, for the domestic water, we use generators, and today, like we need to have very good and crazy ideas to make it work, like to use a local fuel, or to try to repair, or to take one or spare part, or to buy one which is broken, but he has the piece that you need for another one. So it's really like puzzles to make any activities. So I would say that most of them had some easy moments and complicated moments. When I left in July, it was really the domestic water and generators the main issues. If that answers the question.
And if I can add things, as a manufacturer, we usually lose the link with the user, which is a little bit a shame. And but we are trying to keep that through the organization, NGOs, or other partners which are implementing the systems. But usually, at first, we upstream, we are training the teams which are purchasing our equipment. We are doing a lot as well of a demo and presentation all over the world, just to let people know our system, because it seems that it's not totally new, this energy recovery RO. By the way, I will do a little bit of advertisement, but we have a presentation on October 9th at the Swiss Embassy in Nairobi in Kenya of these systems, and that could be useful for those interested to join. Please let me know. But we are doing quite often this kind of events and demonstration just to sensibilize and to train people with the use of our equipment. And we have a technical support, which is represented by Andrew here, who used to be, but now he's moved a little bit of job, but he's still in charge of that. But Andrew solved some issues that Maud had been in contact. I mean, Maud has been in contact with the team using our Aquifer 4000 in Gaza, and there were a few issues in operating it, I think very small ones, and she could, through me and all the network, be in contact with Andrew, and I think we could fix it pretty well. But the best would be to keep the contact and to have a tracking of our equipment. But an Aquifer 4000 is usually mobile in a box, so it's not so easy. With a fixed one in a container, we have a connection system which helps to supervise, but with these more mobile one, I think it's more complicated, and we want to keep it simple as well. So that's what we do. We work upstream, and we try to train before we deliver, and when we deliver, and then we're available.
Great, thank you, Stephen. All right, we have a question about maintenance and the availability of spare parts. There's a question to all experts on, do you have any experience to share or any systems that have worked well to change the parts of the technologies you've put in place? And is it possible to share these types of documents? And if so, in which countries?
Maybe I can let Andrew answer on that, because I have no background for that myself, but I don't know if you have any, Andrew.
Yeah, I mean, day-to-day maintenance on our systems are pretty minimal, outside of turning the system on, changing a filter, flushing the system after using it. So in terms of day-to-day maintenance, it's pretty low. Anyone with a few hours of training can operate the system. Deeper maintenance, such as maybe a pump rebuild due to damage, that's a little bit more in depth, but it can still be accomplished on site with standard tools as long as you have the requisite rebuild kits and parts. So that maybe is a little bit more in depth to crack into a pump and actually rebuild it. But in terms of day-to-day maintenance, it's fairly minimal with very basic training.
Mud, you can answer, and I just want to add Tim's question, which is especially for the case of Gaza. Tim asked if you found the supply for rehabilitation in the local market there, and if some spare parts were available, and if so, is it possible to import? If not so, sorry.
Okay, I think the first question was from Erizo. So just on this, on my point as humanitarian person, I would like to emphasize the fact that there is different systems, but every system has to be adapted to the context. Like spare parts need to be here, people need to know how to use it. Any system can be good, it has to be adapted to your water quality. And also you need to make sure that RO or desal unit is the thing that is needed. It has to be the last resort. It's not something like you can use for any context or whatever. You need also to look at the resource, the recharge, and that you will not completely dry the place. Also, as we said, there is the brine water that you need to be careful about, take into consideration to make people being able to still cultivate or whatever. So for me, it's really something important to make sure that you will not spend a lot of money for a system that was not the good one, or maybe not will not be used correctly. So I will not say that there is, of course, there is experience in many countries, I guess, and I'm not sure that there is like specific RO for each place. So maybe you need to contact different NGOs or different suppliers to see what's happening, what can be used. So that's for me the first one, and the second from Timothée. So we started to work with ROs in Gaza in July 2024. So at that moment, there were ROs and there were spare parts available. Then we managed to bring some membranes by ourselves, like with the expats in. But after we were not, since July, I think we are not able anymore. Or it's really like depending, so it's not a sure thing. Some like UNICEF, MSF, they managed to bring some spare parts. Yeah, it's what was lately, but after July, really after mid-July, I have no information, and I'm not sure it went better. So that's it. The main issue was chlorine and anti-scalent also. And just because I will also make some advocacy, some advertisement in Gaza, guys. We need to chlorine the water. People are drinking non-chlorinated water. Most of the NGOs, people there are saying it's because they do not have anything to check the chlorine. Pool tester is very easy to import with expats. Just put pool tester with your expat, DPD1, and that's it. Yeah, that's my message. Thank you.
Thanks, Mud. Clear message. We heard it. Maybe I saw Nicolas' question was answered by Stephen in the chat. Yes, Andrew?
Yeah, I just wanted to make a comment on the waste and brine. Hope I'm not jumping ahead too much, but it's not something we have currently available today, but we do have an emerging technology that we've proved the concept here at the factory of a brine recirculation loop, which works in a batch process. Brine recirculation isn't necessarily unique to us. It's been done before, but we've tested here at the factory a batch process where we start with low TDS water and we continuously reintroduce that brine so it's not totally wasted. We reintroduce that brine into the feed, and then as that climbs too high to where it's not sustainable to make water, at that point we dump it and it turns into wastewater, and then kind of start that process over. That's not something we have currently available on a product today, but it is an emerging technology that that is definitely part of the future plans.
Sounds great. Thanks for this. I'm going back to the questions that were raised in January at the workshop, since I don't see any other ones in the chat. If you have a question, feel free to raise your hand, and you can also, share it live on the mic. Maybe a question to Favor and James. It's a question especially on the context of Yemen. Someone was wondering if you could rank the main challenges of desalination based on your experience exactly in Yemen and the different limitations there. How do you prioritize between the environmental impact, the technical complexity, the energy cost, the energy dependence? How do you decide what's your priority and how do you rank the rest of the elements?
James, you want to go first? Okay, thank you. Yeah, I think we talked through this with our colleagues before, and it's tricky because then it depends on also a number of other hidden factors. So, like for example, environment didn't appear like top for us at the beginning. If I was look at like Code Behind, but if I went to a place like Aldale, then environment will come high. Reason being, Aldale is an agricultural area in Yemen. So we had to really think about the brine disposal. About energy, then again in Korbihan, it was not an issue. As I mentioned, sunshine, they had like sun is available the whole year. But in Aldale, you have it like half a year, probably for 3 months to 4 months, and then the rest of the year, then it's when it's sunny, because then there is a lot of the rain. So it was a little bit of a mix, but loosely translated, the cost, I would put it at average. When we started at the beginning in Korbihan, we were not very sure how much the technology would cost, and we were like all of us top on our heels trying to imagine some unimaginable cost, and it was a lot of back and forth even with the donors to try and convince them that we can be able to do it. But when it came to Aldale, because we had already done it, we discovered we could get these materials in the country, so the costs actually went lower. I would loosely translate. I remember to set up the unit in Korbihan, we actually were working with a budget at the beginning of around 50K, but we did not spend the whole 50K. We brought it down to around 40 something. But when we went down to Aldale, it actually was able to come down to around 30 something just to construct the unit. That is ignoring the other cost of the community volunteers that you have to train to work with them and all those other project related activities. Now, having said this, the other thing that also we were looking at is actually on the element of now, when it comes to the energy, we did not think about recirculation. Probably, I think, and I like what Andrew has mentioned. Maybe if we were to go back and maybe do a third unit, we might want to try and think about that to see how we can incorporate that. We never thought about that, but ideally what we were looking at was looking at the available technology which is in country, which, as I mentioned, we had a lot of the community members that already have engineering background. Number two is when we came to providing supplies, because we imagine they'll need filters to keep changing from time to time. My colleague Maud has talked about chlorine. We had to make sure we provided the chlorine to the community. And so there are a few things, like the first one, we had to buy a lot because we didn't know how long it would take. But the good report we had is that after running it for 2 years, we did not have any problem with the membrane. And I'm really happy when I heard Stephen talking that probably 6 to 8 years. I'm really hoping 6 years down the line, we'll go back to Yemen and still find that our membranes are still functioning and that they have not had any problem, and really would be very happy if that actually would be the case. Yeah, thank you.
Yeah, thank you, Favor.
Welcome.
All right. Maybe considering the time constraints, maybe one last question that was asked by someone in the anonymous Q&A online over the last 2 weeks. And I think this will probably resonate with Marielle, who's in the call as well. But someone writes, in the Middle East, groundwater reserves, aquifers, are already overexploited and in decline. How can we ensure that desalination does not exacerbate such situation? Apparently, we often hear that it takes 2 liters of salt water to produce 1 liter of fresh water. Is it still the case or not? And basically, how can we by trying to answer to a problem, not create another one or participate in the environmental situation, which is worsening? That's a question to all experts, so feel free to take the floor.
Yeah, I mean, one way that can certainly be improved is with energy recovery and with the fixed recovery rate. It's just one way to keep overall brine discharge down. I don't have that much more to add than that.
Yeah, just on my side is that this is quite a reality, not only with reverse osmosis that we can like deplete all the resource. So I think it's also like our work to make sure that we are not doing this. And we have some data to make sure that we will not deplete the resources. And for the brine also to consider by knowing, like on my side, I really think maybe not in development or humanitarian, but for emergency, that if like in Gaza, the system was already existing, they were used to it, so they also had a way to manage the brine more or less, which is not existing anymore, but whatever. And they also had like a big study on the recharge and how it's possible, how much is possible to pump and so on. So it was also like part of all the global study on, is it the best strategy to use this system or not? So I think we also have this responsibility to think about it.
Yeah, thank you. I see there was one hand raised, and maybe it's great to finish up with a question live. Charbel, do you want to take the floor and ask your question? We're sorry for running a bit over time. If we have to lose some people,
brief with this. I'm Charbel. I'm with MEDEF Lebanon. Since this is for the Middle East as well. Aquifers are already overexploited. This is a fact, and we're facing that in country at the moment. Therefore, and as was previously mentioned during this session, that reverse osmosis or desalination are the last resort. So usually the first resource would be surface water collection through rainwater harvesting, creating ponds, dams, whatever, any type of technology that you can just make use of your surface water prior to going into aquifers, underground water, more and more. And definitely RO systems can, since they are that much of an expensive ordeal, let's say, they would give you the motivation to look into other, let's say, other options before trying to venture into an RO or desalination plant, because it is expensive and it has its own challenges coming with it. And to answer the question for the brine discharge, with the new emerging technologies, with the staging of the systems, and with the higher efficiency of pumps, the discharge, or let's say the efficiency of RO systems are increasing extensively, especially also to add to that, the energy recovery techniques. So these are allowing us to gain better and more optimized treatment. That's all what I have to say. Thanks.
Thank you, Charbel, for completing the answer and really underlining that it's the last resort and it's not the first option we have on the field. Laure, did you want to add something to the debate?
Yes, hi, good afternoon. I'm going to be very quick. I'm Laure Laroquette. I'm the technical advisor for water resources management at SI. That was actually my question about the depletion of groundwater. I just wanted to say that definitely it's great to hear that technology is evolving with this brine reinjection and all of that. But sometimes water access is a social issue. And so some of the solutions are not engineered. And I'm talking about Yemen, for instance, where 90% of the water in Al Mocha, for instance, is used in agriculture. And water is pumped 24/7 with very high yield. It's fresh water in the valley. And the communities who only have salty groundwater actually go there during the night to get some water and go home because there's not enough water from the salty groundwater. Instead of trying to build our system in the middle of a rural area where it's going to be costly and probably not really sustainable, there might be a way to actually work around water allocation, water resources sharing, and maybe like a social way to solve the issue. So yeah, just wanted to mention that.
Yeah, thank you, Laure. There was a question as well this morning on how do we involve communities and make sure that our answers are not only technical, but also sociological and taking, into account the different power dynamics and the different accessibility for the communities on the field.
Yeah, it was Laure's question.
Oh, it was?
I
No.
think so.
Yeah, I think it was mine as well.
And Andrew, you wanted to add to that?
Yeah, I just wanted to jump back in and be a little bit more specific about the brief answer I made, and I'll keep this brief. That our 50% recovery obviously is a liter in, half a liter out as product, half a liter out as brine. But the brine recirculation loop that we've tested at the factory, we've achieved as high as 95% recovery before we batch it out and start the process over. So again, not something we sell currently, but something that's in development.
Okay. Great. Well, thank you everyone for adding your own expertise to the question, and which really proves that we need this kind of calls and discussions where we give each other's perspective and we work on different contexts. It's always great to put that in common. Stephen, maybe for one last comment.
No, but you can finish. I just want to say, could we have access to all the questions that have been raised in the chat as well?
Yes, absolutely.
And the contacts, because there were a few I could not answer, and I would like to do it afterwards.
Yes, sounds good. We'll send the chat to the different speakers, and we'll also have the recording available probably on the French Water Partnership YouTube channel. And we wanted also to share with you that as you remember from the introduction, this is an ongoing webinar. We're going to have the next one on December 12th. And if you are here today because you saw it on LinkedIn or someone shared it to you, feel free to write your email address in the chat so we can, invite you directly to the next discussion on December 12th, and you can find it easily. But thank you all for joining. It's great to see such an active and passionate community of Humanitarian WASH. And yeah, we'll make sure to follow up with other resources, the presentations from our speakers that we really thank very much. And yes, we'll see you again on December 12th.
Thank you, everyone.
Thank you.
Thank you.
Yeah.
Thank you, Andrew.
Thank you very much.
Thank you, bye.
Bye-bye.
Thank you very much.